Another important aspect that I would like to show you, let's just get out of this user Tom and clear the terminal. So another aspect related to this security is the idea where we can use TCP wrappers to block or allow certain services. And let me just show you what do I mean by that. In earlier days of Linux, there was a service and it was an internet daemon in fact, and what it used to have is that it would combine multiple services under one file, maybe for example inetd.conf, and in that configuration file it would have like TFTP service and FTP service, maybe telnet service, and so on and so forth. And the benefit of this internet daemon, or as we call it sometimes as super server as well, so it's like a super server because it is taking into account all of these services. So super server, the benefit is that you see, if I run this service FTP, if I run this service, then it will be on and it will keep on listening on port number, let's say 21, right? Now once a user request comes in on port number 21, then the connection will be established, and whatever the user wants to do, maybe he wants to put the file or get the file, he will do his things and then get out of the system. Now while the user is not connected to the system, this port will still be open and listening in the listening state. Similarly, it would be true for telnet and TFTP and all of the services that are being used on the system. What inetd daemon does is that it takes all these services into account and does not run those services at all until and unless a specific request comes in on port number 21 or port number 22 or whatever port or whatever program or service that is listed in its configuration file and whatever port it is listening on. So let's say if we have got SSH service listed in inetd, and once we make the request, at the moment there will be no port listening on port number 22. But once the request comes in on port number 22, then SSH will not be listening to that request, rather internet daemon will be listening to that request. And once it listens that the request has come on to port number 22, which let's say belongs to SSH, then it will hand over that request to SSH service. So it's like inetd is, or I should put it like this, inetd listens to requests, then if it is let's say port number 22 request, it will forward it to SSH service daemon and then it will be started for that particular duration, and once the user gets out, this service will be closed. Similarly, if another request comes in, let's say for telnet service, so this telnet service request will be sent over to telnet daemon, and then telnet daemon specifically will be started. It will serve the purpose till the time user is logged in, and once user gets logged out, this telnet daemon service will be blocked or rather shut down. Now you might guess that definitely if a service has to be started at that particular time, then definitely it would induce certain lag, and also there were some security concerns as well with inetd. Now this inetd is not used anymore, but just wanted to let you know about it. Now what we have in the systems is INEX or X-INET daemon, and even now this is not used. Now we know that services are started using inet or even now system control or systemd, or in case of Ubuntu we use upstart. But you should know that X-INET is definitely in there, and we can start or stop the services using X-INET. And just in case you are wondering what this X stands for, it's extended. So extended, internet, and D for daemon. So the purpose of this inetd or X-INET, as I was telling you about, is the TCP wrappers. TCP, let me write it clearly. What is wrong with my handwriting? So TCP wrappers. And we call it TCP wrappers because it takes on TCP, and it could be UDP service as well over here. It takes on these services, it kinds of wraps them up and provides one interface to the clients outside the machine or outside the server, so that users do not see specifically these services, rather they just send in the request and inetd takes care of the rest. Now let's head over to the terminal and see if we can find the configuration settings for XINET-D and how we can put in services in there. So I'm here at my Ubuntu box, and let's just type in, let's say, ls and etc and XINET-D. Okay, so XINET-D maybe it's not available in here. Okay, so we can install it, although it's not required, but just to let you know and show you, I can install it and show you some of the files. So let's just quickly install it by typing in sudo apt get, because on older Linux distributions and on many of the installations, I would say, we do use this XINET-D. So you should know that how does it perform and what does it generally look like. So I put in install and XINET-D and just put in my password. Just give it a while, and while it gets installed, I'll take you right through some of these configuration files. Now it's done, and let's just do ls and etc and XINET-D.D. So this is the directory, and we have got some of the services in there. Also, we must have got the XINET-D.configuration file, which we do. So let's have a look at the entries of this configuration file, XINET-D.conf. And this says over here, it does not say much anything. It just says that go and look into this directory, which is etc XINET-D.D. In inet.conf file, which was the earlier version of XINET.D, we used to have multiple entries in here, which would correspond like the service name, and then whether it was stream or what was the type of that service, and then the port or the protocol, whether it was TCP or UDP, and then the port on which we wanted that service to run on. But since this is XINET-D, so things have changed, and now we have got separate configuration files against each and every service, which are placed in XINET-D.D directory. So let's get into this directory, and instead of getting in, let's just simply open the file, one of the files. Let's say, let's open this, maybe discard or echo or time. So either one of these. I put in XINET.D, and let's just try to open time file, and we see that default for this service is off, and these are the fields that used to be there in the main configuration file, but now they have been put in each separate file against each of the service. So whether we want to run this service for TCP or maybe UDP, and what user will run it, it will be run as root. And also we see that at the moment this service is disabled. So what we can do is that we can enable this service by putting in, let's say, no over here. So I type in, and this read-only file, so I need root privileges to edit this one. So I do a sudo and come over here all the way and do a no, remove this yes, save the file, get out of this. And now I also need to restart this service. So I can do that using init controller or also the service command. So I type in sudo service and then XINET-D, then restart, and now the service has restarted. And now what we should see is that this will be listening for that particular port. So let's use that command netstat -ant, and now we see that it is listening for this port number 37. Let's see what this program is against for this particular port that is listening on. So I can do put in sudo, and then the flags are maybe UDTPL. So I press enter, and let's just see with that port number 37. So this is the one. It has changed it into service name. So let's put in -n flag as well, so that it does not do that. And now if I bring it up, now let's see that it has changed to port number 37, and look at that. It is not saying that this service is against time service, or this port is against time service. I correct myself. This port, it is saying that is against XINET-D. because the time service is now wrapped up in X INET D. So now time is not listening directly to this on this port, rather X INET D is listening. And once a request comes in for port number 37, this X INET D will start the process of time service and will send the request or the packet towards the time service. So that's one way to secure or wrap our services. And just to add a security aspect of that, there are files that we can use to protect our X INET D service from legitimate hosts or the host that we allow. So those two files are host.allow in etc and host.deny. Let me show you those files if they are in there. So I type in host. So these are the two files that I'm talking about. Now if we allow a host in here in allow host.allow, then this will take precedence. Even if we deny a host in host.deny, this will not take the precedence, because first this file is checked and then host.deny file is checked. Let's have a look at the syntax and contents of this host.allow file. So I type in, let's say, vi and host.allow, and also you need to have root pages to edit this file. So it has also given this example that if you want to put in this first one, this is the service name. Then this next field over there, this one, this could either be the host name of the machine or single IP address, or even the network we can define over here. And afterwards, some other options, for example, we want to allow something or deny something or whatever action. So I can type in something like maybe FTP. Let me just type in FTP, and then fields need to be separated with full colon. And afterwards, if I want to, let's say, block a complete network, so I can say, let's say 192.168 maybe I can leave it over here as well, so that any number after these, let's say 23.24, it will be blocked or allowed if we are using host.allow file. Or if I leave it just here like that, then all the IP addresses appearing after this will be allowed. And after that, I can put in the option whatever I want to do. I need to put in full colon, of course, and then I can write in allow or maybe deny. Mostly allow or deny are used. And now once I have made this entry, then before making this entry, any IP address would have been able to use the FTP service on this server. But now, since I have added this entry, all the IP addresses that have got this field in there, 192.168, only those IP addresses will be allowed to make FTP connection to this machine. So this way we have not only used TCP wrappers, but we have also exploited the functionality of host.allow and host.deny file to somehow add another layer of security to secure our services. Now the last thing that I want to tell you about is the concept of firewalling, and in Ubuntu and Debian is basically controlled by IP tables, while in Enterprise Linux this is controlled by a firewall daemon, which in turn does use IP table. So let's just get out of here. And also I would like to stop this service so that this X INET D service, because the thing is that I want to show you, I do not want this service to be running at that time. So let's just stop this one, sudo service and stop or service name rather. So X INET D and then stop. I given my password and now the service stopped. Now at this moment we saw that this port 22, it is listening the request. So what I can do is that I can, at the moment, since I'm already in, so I do not want to close this session. But what I'm going to do is that I'm going to make an IP table entry so that I would not be able to make SSH connection to this server anymore. So let's see how we can do that. So the first command that I'm going to use is sudo IP tables and then -l to see what are the current entries in the IP table. And we see that at the moment there are 3 chains: input, forwarding, output. let's just not delve deep into them. It simply means that input means that if a packet is coming into the box, output means if a packet is going out of the box, and forward means that if a packet comes in the box and maybe tries to go out on a separate interface. So all of these are in accept state at the moment. So it essentially means that any packet can get in or get out of the box. Now what I'm going to do is that let's try to create a rule to block SSH connections from a particular machine. So type in sudo iptables, and since we want to add an entry into the input chain, so it means that I want to append something in the input chain. So that's A for append, and input is the name of the chain. Then I can define what protocol that we want to stop or drop or stop or allow. So the protocol is TCP, and the destination port is SSH. So I type in D port. This is just the syntax of iptable, so you need to remember it. And then what is the source address that the traffic will be coming from? So the source address is 192.168.1.2, and then the action that we want to take. So the action is, let's say, drop. So this rule is simply doing that, adding a rule which says that any traffic from this particular host going to this port SSH should be dropped. So now I press enter, and if I do, and let me just check it, and you know, as soon as I added this rule, my connection has been dropped. So now since I am out of the terminal and I have also already blocked this IP address, so what I can do is that I can change the IP address of my machine, and then I can get back into this server. But now you know from this example that once you are doing or playing with firewalls, then you must not try to block the IP address of your management station like what I did in this case. It should not have been dropped because the already established connections do not usually get dropped, but now you know that you need to be careful. So let me just open up another terminal, and let me also change the IP address, and then we'll try to connect to this machine one more time. Alright, so I have changed the IP address. Let's just pull up the terminal, and let's just type in SSH and the IP address of that machine, which is 192.168.1.20, and now we are logged in. And if I do, let's say, W, or maybe try to do netstat -n with more, then it shows that this is the connection. This is in fact this is a separate connection, but this is the connection that is just established now. I've changed my IP address to 1.3 so that I can get connected to this host one more time. So that was just a quick overview of how you can use iptables to get connected to your machines, or maybe block or allow certain ports or certain IP addresses, or maybe certain service types. Now, since I told you that LPIC certification does not cover this topic as far as iptables and firewalls are concerned, but now you know the basics of that how you can accomplish this task. There you can consult its manual. It's a lot more details in there how you can use iptables, but this is one service that you can definitely rely on. So I hope you have learned from this video, and I would like to thank you for viewing.